Okay, so we are recording this class with your permission. Let us talk about some of the important aspects of computer hardware. Okay, so we will be discussing both input as well as output devices. Okay, and the peripherals. All right. Now, peripherals are what we call, things like this: mouse, and so on. Your sound systems, the externals that you attach to a computer system is what we call peripherals. Okay, so now we have to begin with monitor. Okay, now see, a computer by in itself is perfectly capable of functioning. Okay, but there have to be certain devices that are needed to input data, and then we need certain other devices that can help us to look at the data or the result of the data that we have created. Understand? So that is why we have what we call both input as well as output devices. Now, a computer is pretty much a processing device. Okay, it processes the data that is given to it, but for it to process the data, there has to be some way of putting in the data, feeding it the data. Then there have to be chips within the computer to process the data. So the command has to be given. So for input of the command also, you need an input device. Understand? Then once you have done that and you want to take a look at the result, how do you do that? And that is what we have the computer, the output for. Understand? So what we're looking at here today is the monitor. Okay, and the various kinds of monitors. Okay, see, the fun part about computer technology or any kind of technology in the 20th and 21st century is the rapid advancement of these technologies. Now, when we say rapid advancement, it is not just about the speed with which the data that you enter is processed. No. It is also about the size to which the technology is managing to reduce things, to shrink things. That is also important. So if computers, when they were invented, were the size of huge rooms, what we used to call supercomputers, the very idea that they had been shrunk to desktop size was a marvel, was a great advancement. Then, thanks to more and more technologies that evolved in the fields of chemistry, in the fields of physics, in the fields of even biology, through those advancements, what happened was that the computers began to shrink further and further till they have come to be worn as what we call wearables today. See, a computer is not just a thing that looks like the computers that you are familiar with. Okay, anything that is capable of computing data that is fed into it is, technically speaking, a computer. So if you're wearing a watch or a glass, your spectacles that are capable of reading data, and of not just receiving but also emitting data, it is a computer. For example, those smartwatches that we talk about, when your phone rings, you can see on your watch who is calling. When that happens, that means that it has received, your phone's data has been received by your watch, and that has been computed, interpreted, and the output is there for you to see. Understand? So technically the wearable is a computer, not just technically, otherwise also it is a computer. So this is what basically you have to understand about what a computer is. So if you think about it, is a calculator a computer? Sure, it is. Are you putting in data? Yes, you are. Is it computing your data? Yes, it is. Is it giving you an output? Yes, it is. Understand? So it is all a matter of your interpretation. It's a matter of how you are looking at or what you consider computers. Anyway, but please don't say that a car is a computer, because you are feeding it petrol and then you start it and you drive it. So that is your processing, and when you reach your destination, that is the output. No, it's different. Okay, so now let's take a look at the kind of computer monitors. Now, in the beginning, there was what we call the CRT, or the cathode ray tube. See, the cathode ray tube was a very interesting concept, because I've been fascinated by cathode ray tubes. Okay, I don't know how many of you have seen those TVs that had those bulging glass screens. In fact, computer monitors also, that used to be huge, and they had this big back at the back. Okay, and everything came in those interesting numbers on screen. It was beautiful. Okay, so these monitors, they employ what we call CRT technology, or cathode ray tube technology, and was generally used for television screens, but then that got co-opted to the monitors. Okay, so what happens is, very intense stream of high energy electrons. Okay, an intense stream of high energy electrons are introduced into a tube. Okay, and this is used to form images on a fluorescent screen. That is how the cathode ray technology works. Okay, so and there is this vacuum tube which has this electron gun at one end and a fluorescent screen at the other. So literally, the cathode ray tube is there. It's a vacuum, understand, and there's a emitting gun at one end and the screen. So technically it is like, it's like projection technology. So the light is emitted, it hits the screen, it passes through the cathode ray tube and it hits the screen, and the screen lights up. Okay, so that, okay, so now cathode ray monitors are kind of outdated, and not only that, they contain extremely let's say harmful, or polluting residues, when they are broken down and so on. So, and not only that, they were heavy, they were bulky, they consumed a lot of electricity. So on account of all of these things, cathode ray tubes gradually fell, monitors gradually fell out of use, understand. So that is why nowadays you don't see those huge computers kind of a thing. And not only that, they underwent a lot of wear and tear also. The pictures were not that clear, it was not that much of fun. Okay, the definition, see, as time progressed, people began to want more, they wanted to experience more. In the 19th century, there was everywhere a genteel poverty that existed. People were equally poor everywhere, understand. Even the rich were in a way poor, particularly in countries like India. Then what happened is, by the time the 20th century came about, the 1990s came about, there was globalization, understand, and people were cross-referencing. There was a great deal of prosperity, economic benefits, the things that we have talked about in the past. Okay, with all of that, what happened is the spending power of the people increased. Okay, which means that their purchasing power increased. See, when you spend, that means you're literally purchasing something. When their purchasing power increased, they wanted more choices. And here's what, and technology was developing at that kind of a pace to satisfy those demands, understand. So that is why things like cathode ray tubes were not enough or competent enough to support the technology that was fast evolving, understand. So these cathode ray tubes had 4 is to 3 ratio of display, 4 is to 3 ratio. But then from there, things went on to LCD and LED monitors, and in LCD monitors, the display was 16 is to 9, that is the ratio. Okay, so with that, things began to change. Okay, yeah, so now we will talk about, did you understand the CRT monitor idea?
Yes, ma'am.
Oh, good. Okay. Now we will
Yes, ma'am.
be, yeah. Shall we then talk about the LCD?
Okay, ma'am.
Okay. Any idea what is the full form of LCD?
Liquid crystal display.
Liquid
5 points.
crystal display.
Yes, liquid crystal display. Okay, now this just means that it's made of liquid crystals, understand, and it is the most commonly used sort of monitor, and it requires very little space. It is thin, okay, and it requires less electricity, and also it does not heat up as fast as the old CRT monitors. I don't know if how many of you have seen a CRT monitor or a TV or something. Anybody?
Yes, ma'am.
Yes, ma'am.
So when you switch it on and you use it for some time and you switch it off, then it heats up. It takes some time to cool down, which means that it is easy to know whether you had been watching TV or not. Okay, but with an LCD monitor, it is slightly easier. It doesn't heat up that fast. It is kind of okay. And it is way more elegant. It is way better. And with the monitor's display getting wider, it kind of seemed more sleek. Okay. Now the you have up to from 17 to 60 inches of display for computers. Understand? I know somebody who has a 36-inch monitor. Okay, I was like, then why are you even having a TV set in your house? Understand? So anyway, so you have LCD. Okay, and then I would like to take you one step. One of the things is that there was sharper definition in an LCD screen. There was sharper definition, and also it has less chance of getting spoiled. See, Chalpoka, in our old TVs, the cathode ray tube TVs, TV adichipo. It would just get spoiled. Then they would be like, oh, we have to change the tube, then you have to change this, you have to change that kind of a thing. But an LCD has a longer life. Understand? It is on account of the fact that it is cooler. It doesn't get heated up so fast. Okay, and there's better definition also in terms of the image clarity and so on. Okay, yeah. And not only that, see, the LCD monitors had better integration with devices like speakers, with devices like USB ports, etc. If you are using an LCD screen TV, then it is kind of easier to use it with these ports, because some of these ports come built in with them. Understand? And not only that, the kind of technology evolution that has taken place has factored in all of these things. See, there was a time when there was this very cheap joke that used to be made, about why computers are like men. I don't support it at all, but anyway, they keep saying, no, why computers are like women. And one of the things that was said is, if you wait for 6 months, a better model will be available. Okay, so I mean, oh come on. Okay, so that kind of a thing used to be there. So this is why I'm saying, see, there was a point in time where computer technology was developing so rapidly that if you just waited for 6 months, then whatever you have right now would just get outdated, because something else, something better, something faster, something sharper, brighter, more defined would come about, something more advanced would come about, which would have more functions than the others put together. So this was how it was working. Okay, but now thankfully all these processes have slowed down, because it's reached a sort of saturation point. Okay, then apart from LCD, you have something called LED. What is the full form of LED? Anybody?
Light emitting diode.
Oh, you people know everything. Is this taught, or is this just your general knowledge?
Ma'am, I studied that module a few days back.
Oh, that is interesting. Good. Oh, അപ്പോൾ നിങ്ങൾക്ക് ഈ LED LCD ഒക്കെ എടുത്തിട്ടുണ്ടോ? It's done?
അല്ല മാം സ്കൂളിൽ പഠിച്ചിട്ടുണ്ട്, കമ്പ്യൂട്ടർ പഠിക്കാനുണ്ടായിരുന്നു.
Oh,
Yes,
nice.
11th and 12th also.
Okay, cool. Okay, so
കൊച്ചിലെ തൊട്ട് തന്നെ പഠിക്കുന്നത് മോണിറ്റർ കമ്പ്യൂട്ടർ.
okay, so anyway, LED is light emitting diode, and it is also a more recent innovation than earlier. Okay, and these are slightly curved, or they even have completely flat panel displays, which use the light emitting diodes for doing backlighting on the screen, instead of this CFL, cold cathode fluorescent backlighting. Instead of that, what they do is that they use the diodes to emit light. Okay, and many of them with the pixels and so on. And LEDs are brighter because they are capable of 4K resolution. Okay, compared to the other displays don't have 4K resolution. Okay, and so what happens is that sunlight doesn't affect the LED screens. See, sometimes when your screen is in sunlight, you're not able to see what is happening. The image fades, right? With cathode ray also that happens, with LCD also that happens, but with LED the display is as bright as ever. Okay, so you don't have to worry about any of those things, which means that for all visuals that require high graphics or HD, high definition sort of graphics, all of these things, LEDs are the best. Okay, they have higher contrast, they have more vivid colors, and they are more environment friendly because of their longevity, their long life, and at the same time, they can be broken down much more easily. So they are kind of more friendly towards the environment. And they are way more durable also. Understand? Yes. So, but LED monitors are way more expensive than LCD monitors. Cathode ray tube is now pretty much out of the market, but still. So, yeah, anyway. Now, there's no distortion of images also in an LED screen. Understand? Yeah. Now, another one that we have is what is called OLED. Okay, any idea what OLED is? You see it on Sony and Samsung televisions. What is OLED? OLED. LED, light emitting diode. OLED is organic light emitting diode. Okay, so that is made out of organic material. Okay, carbon, plastic, wood, polymers, all of that is what is used. It is used to these things are used to convert the electric current into light. Okay, now they are the things that come in a lot of televisions, lot of phones, lot of handheld devices, palm held devices, smartphones, etc. You find them. Now OLEDs are even thinner and have a higher contrast ratio compared to LCDs. Okay, so this is the I think you might have gone into electronic shops where they're selling those TVs where they say 4K resolution, OLED, curved screen, so you can see everything, that kind of a thing. And the pictures are way too clear. In fact, they are so clear that I don't like them. Have you seen those extremely clear televisions? Do you like them?
Yes, ma'am.
Yeah, but I thought it takes away the whole, other than glaze, they take away the entire glaze of the thing, and they just, people are all there, right there. Like, haven't you guys haven't felt that way? You like it? Like, பயங்கர clarity ஆயிட்டு பயங்கர clarity.
They're really lifelike.
Yes, it's too lifelike. So it spoils the whole effect for me. I don't know. I feel like the 4K thing, or the OLED screens make me feel like I'm watching a television serial when I'm watching a movie. Actually, you get the feeling, right? In television serials, you know the clarity with which they come, right? The people and everything like that. But so when I watch a movie on an OLED screen, it makes me feel like I'm watching a television serial or a documentary on Animal Planet or something.
You can make out the difference.
That's the thing. I prefer
There won't
movies
be
to
much difference
look like
between them.
movies. Exactly, that's the problem. Anyway, okay, so that's OLED for you. Anyway, what the advantages that OLED gives you is that it gives you a wider viewing angle. It gives you excellent picture quality, great contrast levels, and the monitors they respond faster. They come on faster. They get switched off faster. They are more energy saving. Understand? And they're well balanced. All the ratios are well balanced. Okay, but the only problem is that you're not. They are very very prone to water damage, and if anything damages the screen, hits the screen, it can cause great distortion. Then you have to replace the screen at a very high cost. Understand? Then you have, of course, plasma monitors. Okay, plasma monitors, they use electronically charged ionized gas. Okay, so that's they use electronically charged ionized gas. And what happens is that there are these tiny fluorescent lights, and they create image pixels. Understand? And each pixel is made up of a tiny neon light, red, green, blue lights that come together to produce a wonderful contrast. Superior contrast ratio is produced. Okay, and very intense light also. So plasmas and all are way better in that sense of the term. Okay, and it reduces your image distortion. Okay, because when you have a perfectly flat screen, what happens is there's greater glare that is emitted. But in a curved screen, that glare is made more gentle. Things start to seem a bit better. Okay. So those are the various kinds of monitors. So what are they? You have the CRT, you have the LED, you have the LCD, you have the OLED, and you have the plasma monitor. Okay, those are the five. Understand? Then you have the CPU. Anybody? What is CPU?
Central processing unit.
Okay. Okay, central processing unit. So literally what a CPU is, that it is the brain of the computer. That's what people call it. Understand? Now but I wouldn't say that it is the brain of the computer. It is actually the processing segment of the brain of the computer, because CPU is not what is the brain. It is a software that is the brain, if you think about it. Okay, so a computer's CPU will handle all the instructions that it receives from the hardware and the software that runs on the computer. Okay, so CPUs have to be fast, they have to be efficient, they have to have the performance of a CPU depends on the chip that is used in the CPU. For example, you have various kinds like AMD. Okay, then you have an advanced version of that which is called the AMD Ryzen. RYZEN, AMD Ryzen, it's called. Then, of course, you have the various Intel CPUs. Okay, Intel Core i3 8th gen, which is mine. You have i3 10th gen. You have i7, i8. You have, okay, and sometimes what is i3 8th gen is actually i7 their first gen. It's all that kind of a thing. So processing units, the processing of the processing unit will depend upon the kind of chip that is in the CPU. So the processor is placed and secured in the compatible CPU socket. Okay, and also to prevent overheating and so on, the processors are covered with a heat sink. Okay, and when the chip is placed in the computer and it is sealed and so on, that is when you say that the motherboard is now secure. Motherboard, understand? Yeah. So now what are the things that a CPU does is that simply it takes the input from a peripheral, and the peripheral could be a keyboard, a mouse, a printer, etc. Okay. Yeah. Then what you do is that, or a computer program, then it interprets the input on the basis of the function that is asked of it, and then it either outputs it to your monitor or performs whatever the peripheral has asked for. For example, if the peripheral wants a print, then the computer will print it. The CPU will print it. Understand? Yes. So that is essentially the history of the CPU. And in modern computers, the CPU is contained in what we call an integrated circuit chip. An integrated circuit chip, you can call it the ICC, and which is then also called a microprocessor. Okay, ICC or a microprocessor. Yeah. Then now, how is the input data transferred? Okay, so the input data is transferred through the main memory to what we call the arithmetic logic unit, ALU it is called. The arithmetic logic unit, for the sake of processing. Now there are four basic arithmetic functions: addition, subtraction, multiplication, division, and there are these logic operations. Adana arithmetic section. The logic operation includes comparing of data, selection of the desired procedure for solving the problem that has been put in front of the CPU, or finding an alternative based method on a already decided decision criteria. Okay, for example, now what I mean by that is, I hope you understood the arithmetic section. Okay, so because see, when you enter a data into a computer for processing, it has to be either based on arithmetic or it has to be based on logic. Okay, you can't for example, do stuff like program the computer, write to the computer in its own language. You can't write to it and ask, how am I doing today? It's not going to give you an answer, but it will give you an answer based on somebody else already having coded there, sorry, I do not follow. Understand? So it knows only two things. One is arithmetic, the other is logic. Understand? So arithmetic, when you're inputting your function, it has to either be dealing with addition, subtraction, multiplication, or division. The processes should be involving something like that. For example, how much is 346 into 7948? Fine, it will do it for you. Or suppose you can input values and ask it for the largest. You can ask your computer, give me the largest. So it will use all of these functions in order to do so. Now the logic unit is what I told you earlier. It compares these data, see, for the largest thing. So it would be like, okay, based on the systems, the programs that are already there in it, that it is capable of doing, it will compare it on the basis of some parameters that are given. See, how do you know that 1 is greater than 2? Is it? Is 1 greater than 2?
No, ma'am.
Yes.
No, ma'am.
See,
No,
how do you
ma'am.
know? How do you know that?
Our teachers taught that.
Exactly. So think of yourself as a CPU into which this data has already been fed. Understand? So now when I input this question to you, okay, you have used your logic in order to give me the answer. So technically, you have functioned as the CPU, and you have used the programs that have been there, input within you, that have been installed in you in order to process the data and give me the result. Understand? Now, for a computer, think of it as as a child to whom these lessons have to be given, and all data subsequently is analyzed on the basis of these comparisons. Understand? This logic has to be applied. Okay, so that is how a CPU works. It works on the basis of two functions basically. One is arithmetic and the other one is logic. Okay, and if you know what it has with it does not apply within the ambit of its logic, within the scope of the logic that it has. For example, you ask it, who is the greatest shopkeeper in the world? Okay, unless it has the ability to compare and select the methodology of giving you this particular data, it will just say, sorry, I do not follow, I do not understand, wrong, 404, not found. See, it will give you all of these options. Okay, or what is going on in my mind. If the computer has not been programmed to guess it, nothing doing. Okay, see, this is where artificial intelligence has kind of overcome this particular limitation that computers used to have at one point of time. Understand? Because artificial intelligence is sentient. sentient, sentient. Okay, sentient is capable of gathering its data on the basis of external observations, on the basis of the existing behavior patterns of the human being involved, human being or human beings involved. Okay, and you can program the artificial intelligence to be sensitive to culture, to race, to color, to age, to sexuality, to sex, all of these things. Understand? So technically, you are teaching a computer to think like a human being. Okay, but again, see, in order to generate a suitable artificially intelligent system, you have to input those programs and put them in place already, so that when the time comes, it can be activated. Understand? So if you don't teach it to read emotions, it is not going to be able to read emotions. Okay, so it's all in the programming, it's all in the coding, is what we have to understand from this. So that's CPU for you. Any doubts about CPU, central processing unit?
No, ma'am.
Okay,
No,
it's
ma'am.
the, like I told you, yeah. CPU, it has ALU and of course CU, which is the control unit, which will direct all of its processor operations. Okay, all of that is there. So the machine cycle is quite interesting. Okay, so there is the main memory. Okay, and what it does is that it takes instructions from the main memory to the control unit. Then from the control unit, what it does is that it will decode the instructions into commands, various commands. Then from the control unit, it will go to the arithmetic and logic unit, and there it will execute those commands. Okay, and then the result is sent back to the main memory to store or to output. Understand? So main memory, the information is input and sent to the control unit. From the control unit, those instructions are decoded into commands. From the control unit, it goes to the commands go to the ALU, which will execute or carry out those commands. Okay, from there it goes back and gets stored in the memory, or it is input. Okay, yes. So now there are some things that you have to keep in mind with regard to a CPU. One is the speed, which is called clock speed. Okay, then you have you know various speeds at which these things work. Okay, and the faster it is, the better it is. See, sometimes you have these very slow computers. How do you call a computer slow? When it takes forever to come on, when it takes forever to open Word. Like when I bought my laptop, it was supposed to have phenomenal speed. Okay, but then I wasn't getting it. It was taking a long time for Word to open. Imagine Word. And then I took it to the service center, and then they told me, see, the thing is that your memory is all in a bunch. You have to compartmentalize it. And then I also put in a solid state drive, an SSD. Okay, that is additional memory into which all these programs and all those things go in. With that, my system became phenomenally fast. So I'm very happy about it. Understand? So, you people have done these kind of things?
No, ma'am.
Okay, never mind. Okay, so and based on the CPU speed is when is that's also determines the price of the computer. Okay, see, AMD, if it's a simple AMD processor, it's going to be quite cheap. But now the AMD Ryzen is something that is quite on par with the Intel core processor wala computers. Okay, computers with Intel core. Okay, so you have AMD, you have AMD Ryzen, a number of different kinds of processors, but Intel is literally one of the most preferred processors that go around in computers. Okay, there's always this ad that says Intel inside. Yeah, so anyway, next we have the mouse. Okay, that is like the sweetest thing ever. Okay, now a mouse is literally an input device, okay, which helps us to control on-screen activities. Okay, on-screen objects. Okay, so mouse is also called a pointer, and it is a hand operated input device that is used to manipulate objects on a computer screen. As simple as that. Okay, now sometimes a mouse can use laser. If you can see this here, this is laser. Okay, or sometimes it uses a ball. Those are those old ones. Ah, those are those old ones. It used to have this ball in the middle like that, and it required that kind of friction. So you have that. Then it could be wired, which many desktops have, or it could be wireless, like this one here. Okay, and whatever movement is detected, that helps the mouse to the computer to move the cursor, cursor, that arrow like thing, yeah, that on the screen, to interact with your files, windows, software elements. Everything is controlled through the mouse. So if your mouse doesn't work, then you are finished. Okay, literally speaking. It's very difficult. I don't know whether your mouse has ever got stuck or it doesn't work or something like that. Then you have to do things, maneuver with the enter key and the up down arrow, and in order to reach somewhere. That makes it very difficult. Then of course, as your tablets, your computers, etc., they have your laptops have what we call the touchpad. Understand? So you can maneuver everything through that. And nowadays, these touchpads have also become quite advanced, where you have the gesture technology, so you can use two fingers to scroll up and down. Okay, three is when you are able to minimize or maximize your screen. Okay, now you can do all kinds of things like that. So yeah, I just lost. Yeah. So you can do all those kind of things. Okay. Now see, the thing is that mouse is a peripheral device. Okay, which sits outside the main computer housing. It is not part of your computer's architecture, but it is one of the most important pieces of your computer hardware. Understand? Yeah. But now, see, again, what happens is, thanks to this kind of advancement, if you don't have a mouse, you might have a touchpad. If your touchpad is, you don't have a touchpad, it is by touch these days. See, your screens are things that, can be touched, and you can use it that way. Many of these computers now come with touch screen technology, okay, which negates the use of a mouse. But because we are Indians, we don't want to spoil our touchpad, so we use the mouse. Okay, I don't know, we are funny that way. Then of course touch screens or haptic screens are also there, which then kind of you can maneuver using the touch thing, so you don't have to really struggle for that. Now you have left-handed, right-handed mice. Okay, and but of course you have the left right click and the right click. The left click produces selecting functions, the right click opens up alternative functions. Okay, then you also have 12 button mice. Okay, 12 button. Sometimes two buttons are confusing, but you have 12 buttons. Just imagine that, how exciting that is going to be. It's a gaming mouse. Okay, so if you're not a gamer, it is completely lost on you. Okay, yeah. um yeah. Now, see, with the intense use of computer systems over the years, and with the coming of newer jobs like programmers, architects, call center employees, all of these things, with more and more industries and agencies using computers, what has happened is that the need for computers to support human body and its contours has become very important, which is why you have ergonomic mice. Ergonomic. Ergonomic. Okay, so that's why you have these curves over here. They will be flatter, so that they can fit in the palm and they can imitate the shape of the palm of your hand and so on. Understand? So you have ergonomic mice, you have ergonomic keyboards. Okay, which are they have those small depressions, and they have better springs, so that you are not injuring your fingers by jamming on the keyboard at all given points of time. Those kind of things are there. Okay, yeah. Then you have travel mice, which are smaller in size. They're really sweet. Okay, they're smaller in size, and they have this retractable cord. Those were the fashion in those times. Those times means about 3 years ago. So you could pull them and it could go back. Okay, so ergonomic mice. Yeah. So anyway, whatever it be, and yeah, by the way, wireless mice run on Bluetooth technology. Okay, so what they have is that they have an antenna, they have a receiver that you attach to your USB cord. Understand? I will you have a USB port, you attach it to that, and you manage to control your mice using those things. Okay, so but then the thing is that suppose you take your wireless mouse and go to another system, you should take your port along with it, you should take your antenna along with it. Okay, 1 second. This Okay, can you see that?
Yes, ma'am. Yes, yes.
Yes, ma'am.
I suppose most of you have it also, but anyway. Yeah, let me just put it back, because if I lose this, then I'm done for. Yeah. Okay, yeah. So yeah, understand. So have you seen the retractable cord wala mouse?
No, ma'am, no.
No, really. Okay, that's a small thing. It's half the size of this, and it has this USB, cord thing over here. You pull it, and it comes. It comes out like that. Then you attach it using your USB port itself, and you will use it. It becomes a wireless, wire mouse. And then when you're done, you'll take it out, and then you just send it back. It will go back in. That's there. It's quite nice. Hmm. Anyway, so the mouse runs on the drivers that have been installed in your computer system. Understand? So that is why. So you can't just if your computer doesn't support a mouse, which is very unlikely, you can't use your mouse. Or if your driver is damaged, then you'll have to reinstall a driver for your mouse. Otherwise it will not accept, it will not recognize it. See, that's look at the way that these systems are all connected. See, one thing, they invent a machine, and then the peripherals come. Why do the peripherals come? Because the use of the machine has become so variegated, so different, so specific, that there are things that are needed to support each of these functions. So as the need increases, as the levels of complexity increases, the peripherals, their sophistication, all of these things also increase. Understand? Yeah. So anyway, so like I was telling you earlier, your touchscreen phones, your tablets, all of these things don't really need a mouse, but they use the same idea, the same concept to communicate with the device. So instead of a mouse, you might be having a trackpad, you might be having a stylus, you might be having your finger. Okay, that can be used. But anyway, um, the wireless mice run on battery. Okay, the others run on the wired mouse that runs on power. Okay, yeah. Now, you did not ask me the obvious question. Before the mouse was invented, what did people do? See, it was not like the computer was invented, and along with the people like, oh, how will we input data? Fine, let us build a mouse. No, that did not happen that way. How did they enter the data? How did they select the data? I mean, go here, go there. How did they do that?
With the keyboard. Is it with the keyboard?
Keyboard, how?
They type in the data.
Yes, absolutely, yes. They would be like open something or the other, and there'd be like open something or the other, YN, and then there would be a light blinking in front of Y. Okay, then
Oh,
you would press enter. That means so it will take that. Then it would be like open file. You have to type a command. Then you be like open file Y bar N. Okay, it will be blinking. Then you don't want that file, you open it by mistake. So then you will move your keyboard left arrow key, you will move it that side, and then it will go to N, and it will click on that, and you have to do all of this running around. So I guess somebody really got tired of doing all this, so they invented the mouse. Okay, that kind of a thing. So anyway, we have 10 minutes left in class, so I will call it a day right now, because ironically my laptop is running out of charge. I have 35 minutes. Okay, shall we continue, or do you want to stop here for the time being?
Your wish.
Okay, my wish is my command. Fine. So we talked about mouse. Okay, now let us talk about the keyboard then. Okay, let's finish off all those things. Now, keyboard is one of the primary and one of the most important input devices that are used in a computer, with a computer. Okay, now you should understand that there was a typewriter, an electronic typewriter, and if you look at your keyboard, it is a kind of carry over from those kind of systems, right? So keyboard obviously has keys or buttons to create letters, for numbers, symbols, as well as perform additional functions. Now, what are those additional functions? Like minimize the screen, maximize the screen, lock the screen, print screen. Then you have things like edit, insert, select. Sometimes if you're watching a movie, it will do play, pause, fast forward, go back, kind of a thing. Okay, then number of functions like that is available. Understand? So now if you look at it, you have generally about 104 keys on your keyboard. Okay, you can start counting if you want after the class. Okay, so you have keyboards that are just keyboards. Then you have something beautiful. Please don't write it like that in your answers, but you have something beautiful like what we call the backlit keyboards. Have you seen those? No one's seen a backlit keyboard? Backlit keyboard എന്ന് വെച്ചാൽ എന്താണെന്ന് അറിയാമോ? Are you people even there? Hello?
Yes, ma'am, we are here. We were thinking about how it would look like.
Oh, it looks beautiful. That is, light comes from beneath the keyboard. Understand? So all the keys are lit up. അതിനാണ് ബാക്ക്ലിറ്റ് എന്ന് പറയുന്നത്. Back to the lighting.
ഇപ്പോ ഉള്ള കമ്പ്യൂട്ടേഴ്സിനെല്ലാം അങ്ങനെയാണല്ലോ, ലാപ്ടോപ്സ് ആയാലും.
Yes, but backlit keyboard ulla computers with backlit keyboards are more expensive. Understand? So yeah, and these backlit keyboards, they are very good when you're using them in the dark, but it's fine, you can use it whenever you want. So yeah, you have the horizontal rows of characters in the keyboard. They are called the home row keys. Okay, home row. Now the keys below the home row are what are called the bottom row keys, and the ones above are called the top row keys. Okay, now you have a QWERTY keyboard. See, most of your laptop keyboards will be QWERTY. Okay, QWERTY, the first thing. Okay, and this is what is emulated in your smartphones also, in your other button phones also. They have the QWERTY model. Understand? Yeah. So keyboards have different kinds of ports and interfaces. The most common ones that you see in slightly older models of computers is the plug-in types, where they have this round shaped port into which you plug it, but which we call PS2 or serial port or AT. Okay, PS bar 2, then you have serial port, and you have AT, A capital, T capital. Understand? Yeah. But then afterwards, what happened is that you have USB keyboards, you have Bluetooth keyboards. Okay, they are wonderful, particularly if you're using tablets or something. You can use Bluetooth keyboards, and they will interface, and it has the entire layout. And sometimes they come in a very compact fashion. Comes in the shape of a box which you can open, and the keys are within. Then some of them can be rolled and brought. Then you unroll them, and those have a USB attached to them. You have to attach it, and it's like a mat. Just spread it out and start typing. Okay, then now what we have is the LED, not LED, they're called projection. Okay, haptic keyboards. Okay, haptic. So what happens is that you bring a small box and you place it in front of, by the side, wherever you want your keyboard to be, and you switch it on, and it beams the light. Okay, and the keyboard is in the form of a ray of light. Understand? And whatever you type on your table using those keys, you can see it on your screen. Okay, so those are the various kind of keyboards. Understand? So now keyboards only differ in their construction and design. Some are mechanical, some use membrane. Okay, keys. Okay, some use mechanical, some use membranes, and some keyboards are like I told you, they can be folded, they can be rolled up. Some use QWERTY layout, but there are some others which use the DVORAK layout. Okay, they come like that also. It's another set of layout that is there. DVORAK, all in capitals, like QWERTY. Yeah. Now, apart from typing up your for typing up text and so on, you can enter commands using a keyboard. Okay, you can use them for various shortcuts. Okay, like Control V is for paste, Control C is for copy, right? You can do those things. Okay, then you can use these function keys, the F5, F1 to F12 that you have. You can use it for various functions. Okay, like F5 is can be used for refreshing your browser. See, normally when your browser is stuck or you want to check it out or something, refresh it, you will go to the corner of the screen and do that refresh button. But if you just press F5, it's a reload automatic. Understand? Then arrow keys can be used to go up and down on the screen. Okay, then you have in gaming, you have these arrow keys WASD. Okay, so you can move your characters everywhere, and you have your numeric keypads. Not all laptops or keyboards, sorry, not all keyboards have the calculator, that the number keys there, but you can use that in that. Yes. Yeah, so the Apple keyboards, on the other hand, use a different kind of function. Okay, for example, their control option and command keys are very different, and they perform very different functions. So you have to, suppose you're using these non MacBook systems, then you will have to learn how to use the other thing when you buy an Apple laptop. Understand? And since they are very expensive, it will take some time. Anyway, okay, so that brings us to the end of this class. Okay, so we will continue our discussion in the next class, where we'll be talking about the other input output devices. All right, any questions? Any questions? No questions, huh? Okay, so shall we meet again then shortly? I will let you guys know. Oh, let me stop recording.
Yes, ma'am.
Okay, thank you.